Hi, my name is Leonardo Silva and I'm going to present the paper Supporting Real Demands in Software Engineering with a 4 Steps Project-Based Learning Approach. I work with Renata Castro and Marice Guimarães, and we are all from the Federal Institute of Northern Minas Gerais. Balancing theory and practice is a recurring challenge in software engineering education. How to provide students with a rich and fruitful software development experience. So one option is to take real-life demands into class. And instead of having teachers playing the role of users, it would be great if we could have also real-life clients. But where can teachers find these real-life demands and clients, and how to bring them to school? Let me show you how we are dealing with these challenges in our institution. So inside the campus, there are different sectors with different demands in different domains. I show here some pictures of these sectors that could benefit from the use of an information system to assist in their daily activities. Engineering programs, they give us the possibility to develop information systems to meet internal demands. Using institution staff members as clients, we call them external stakeholders. And the idea is to use project-based learning guidelines in order to make it happen. In this paper, we describe a case study using different software engineering programs with external stakeholders underpinned by project-based learning concepts to provide students with a real system development experience. So the goal is educational. We are interested in the learning process. And if this process yields useful software, well, even better. The PBL course relies on the cooperation of 4 different programs in the 4 steps we propose. In step 1, students from the professional and technical computer course work mostly in requirements gathering activities. In step 2, undergraduate students take over projects working in pairs to develop the software. Only projects that reach a quality level approved by all stakeholders go to steps 3 and 4. In step 3, systems are deployed in specific sectors, and in step 4, the artifacts produced are transferred to a junior enterprise and they become responsible for support and maintenance activities. Case study implementation. After discussing with potential clients, these were the projects selected. They are from different domains for different sectors, as we can see. This is the allocation of projects to teams. In step 1, we had 2 classes. Class A with divided in 5 teams with 6 students each, and in class B we had 6 teams, one with 4 students and the others with 5 students, each team allocated to one project. In step 2, undergraduate students from the information system program take over projects inheriting the artifacts produced in step 1. So they have to analyze and choose which projects they would like to implement. It was very interesting at this point to see students evaluating the artifacts produced by other students. They realized the importance of writing clean and understandable code and quality of documentation, models and diagrams. So in step 2, we had one class with 10 students divided in 5 pairs. Each pair had to select one project to implement. We had 2 pairs working on the project P2, one on project P5, and other 2 on project P6. two separated implementations for project P6. In step 3, only projects that reach a quality level approved by all stakeholders proceed. So after discussing with the stakeholders, these were the projects selected for deployment. The two implementations for P2 and the implementation for the project P5. But we had this situation, two implementations for the same system, the same sector, and we could deploy only one. So after some discussion, we decided to continue with these two implementations. It was a tough decision. It was necessary to establish specific criteria to select. Systems were being deployed in the respective sectors of the institution. At this point, classes were suspended due to the coronavirus pandemic. Project activities were also suspended, unfortunately. We could distill a set of lessons learned regarding student ability. Lesson 1. It's possible to have students at different levels of education working on the same projects, since teachers separate their activities and adjust the learning level. In lesson 2, we must encourage students to use their communication skills, but it is recommended to have a plan B just in case of relationship problems. In step 1, we had to come up with project P7 because of relationship problems between team 1 and the clients of project P1. And we also had relationship problems among students inside teams. And we had to deal with it case by case. Regarding outcome, lesson 3. If we make it clear for all stakeholders from the beginning what the objectives of the project are, it is possible to reduce the frustration of not having the system deployed. In lesson 4, it is wise to take precautions on legal issues related to software license to avoid false expectations. Some students were so thrilled about the product they were building that they started dreaming about making money out of it. And then I realized I should have spent more time talking about copyright, ownership, and other legal issues regarding the outcome of project courses. Expectation, lesson 5. The mediating teacher has to spend a lot of time managing expectations to avoid frustration. Engagement, lesson 6. Use structured interviews and clear ranking criteria to measure the engagement and select potential external stakeholders. Context, lesson 7. We must adapt our course considering known issues and institution deadlines, having in mind that unknown situations may also happen. Feedback. Communication issues are part of the real experience, and it's worth letting students have a more proactive attitude to get feedback from external stakeholders. So it's normal for students to get feedback from teachers, but if we let them getting this feedback from the clients, it's a very rich experience for them. Misalignment. Lesson 9. Mediating and collaborating teachers should discuss technical issues related to the projects to align their speech. So all the teachers, let's say, they have to speak the same language when discussing technical solutions. Otherwise, it may be confusing for the students. So my final remarks. We describe a case study using different software engineering programs with external stakeholders underpinned by PBL concepts. We applied our 4 steps approach, including requirements gathering, software development, software deployment, and support and maintenance activities. And we could provide students a real software development experience. We could distill a set of lessons learned. And the feedback we received from clients and students exceeded our expectations. So thank you very much.
So hello again. We part of our third paper for this session today, and Leonardo Silva is here with us to answer and discuss any issues that you have. Remember to write your questions in the chat, please, or comments. So in order to start with, I will make a couple of questions. The first one is about the teams. How are the teams conformed? I mean, the students, did you choose the students choose the team, or you, the professors, the instructors, decide who students are participating in each of the team, and then how the teams choose the projects, what criteria do they use?
Okay. Hi. In step one, we have the number of projects. Before creating the teams, we have the projects. And then it dictates the number of students in each team.
Okay.
And the students organize their teams. For example, I say, oh, it's 4 to 6 students, and I leave for them to organize the groups. They decide. And then the projects are allocated by lot. So it's random for them. In step one. In step two, when the undergraduate students take over, there are more projects than pairs. Then the teams are reduced to pairs in step two, and then they can choose. It's allocated by lot, but they can choose. No, I don't want this one. I want. I prefer to get this one. They can analyze the artifacts produced so far, and they can make this decision.
Okay. Okay. Good. We have a question from Ita. He asked, were there the difficulties given to a student's project outcome from step one to students in step two? Imagine that there were weaknesses in the projects that need to be sorted before handing over.
Well, at the end of step one, there are many artifacts produced. And when step two begins, the students can interact with those that participated in step one. It's not mandatory, but they can do that. And they also have the other stakeholders, clients, in this case, the employees inside the campus. And they analyze the artifacts to see the quality. They decide, oh, this project here, I understand the code, I understand the documentation, I can move forward from here, and then they can start. It's yeah, this interaction between step one and step two. They have to do this selection for the projects available.
Okay, thanks. Okay, Maria mentioned that you talk about challenges and questions about the ownership of the software. Did you agree something about that in the beginning of the course? What would you recommend?
Yes, this was something that we missed in the beginning, I think, because there are some regulations about software and other outcomes from project courses, but we didn't think about that at first. But then when students started to think about the ownership, that they could even sell the software afterwards, or use it, or pass it to relatives to use, something like that. And then we realized that we should have talked to them more clearly about these regulations, that the institution has the property of software, and they couldn't sell it like some of them said. And we should have done this talk in the beginning. Now I understand that, to avoid any frustration later.
Yeah. Okay, this is very important. I have another question. You talk about a plan B for communication. Could you explain a little bit about this?
Yes, because there are many occasions when students will interact with the users directly, and relationship problems may occur. And in this case, the plan B is what will we do in case of relationship problems between users and the students. That's the idea of the plan B. And it happened once in phase 1. We had this situation, and the plan B was to look for another project and reallocate students with another project.
Okay.
So it's important to have in the beginning more options, more projects available.
Because this plan B is for you as instructors. It's not for students. If they face a communication problem, what can they do in order to solve this problem? So it could be, I understand, plan B for that the students develop by themselves if they face this kind of problems. That it could be another approach, another approximation. Okay. Another question probably is related to the first one that you mentioned at the beginning. Do you think that there is a place for teaching software in the course and trying it into the project-based learning?
Yeah, I think so, because the students, they have to pass through different steps, different phases, and the projects are long, more than a year to complete. If it goes to deployment phase, it's more than a year. So I think it's possible to coordinate these talks or this subject inside the project, because there are moments of workshops, for example, to present their prototypes, their models, for example, for the users. And in these moments, we can have these talks. I think it's possible, yes.
Okay. Then another question, I have another question about which is the difference in lesson number 9 that you mentioned in your presentation. You talk about mediating and collaborating teachers. So which is the difference?
Okay. Well, the mediating is the organizer, the teacher that is from the beginning, the one that created the project. So it's and the collaborating teachers, they change semester. When the semester ends, we have other subjects and other collaborating teachers.
Ah, okay.
So the mediating it plays the role of like Scrum Master and product owner, and a little bit of both since the beginning.
Okay.
And okay.
Okay. Thank you. Okay. So we don't have more time for questions. Thank you very much for the presentation and for the discussion, and thank you to all the attendees. Thanks.
Thank you.
Bye-bye.
Bye.